Hello guys, welcome back to a new series on the most trending topic, that is IoT using ESP32 and AWS. This will be basic to advanced series where we will see how companies build and scale their IoT products. If you want to build and boost your career in IoT, watch this series till the end. In this series, we will see how to efficiently use different AWS services like IoT Core, S3, SNS, Simple Notification Service, DynamoDB, Lambda. But in this video, we will start with configuring MQTT for AWS using IoT Core. So I will just brush up about what MQTT is, what are few terms you should be familiar with. So in this diagram, you can see MQTT client. A mobile can be your MQTT client. A laptop can be a client. A Raspberry Pi, Beagle, Bone. Your controllers can be your MQTT client. And then here is MQTT broker, which is a MQTT server. So your client connects to the broker using mutual TLS, and the data transfer is done after TLS handshake. So how data exchange happen in MQTT? It is through publish and subscribe model. Consider a scenario that MQTT client, the controller is connected to a temperature sensor, and I want to send the data to the MQTT broker every 2 minutes. So here MQTT broker has subscribed to a topic, that is sensor 1. Subscribe means it will receive the data on this topic. It can't publish the data, means it can't send the data using this topic. Similarly, MQTT client has published the temperature sensor data to sensor 1. Since MQTT broker has subscribed to this sensor 1 topic, it will be received to MQTT broker. The topic name is nothing but a string. Similarly, suppose if MQTT broker wants to read the data at current instance. So what it will do is it will just publish a message on sensor1/read topic, which is subscribed by the MQTT client. It will receive the data on this topic channel, and it will read the data and the current temperature data, and it will send it on this topic, which is subscribed by the MQTT broker. So this is one more scenario. So this is kind of a complete ecosystem in the production environment, where you have a MQTT device or MQTT client which is connected to a sensor, and you want to display this sensor reading on a mobile. So as seen in the previous slide, the MQTT client, that is the device, will send the data to the MQTT broker, and the MQTT broker will further send the data to the MQTT client, that is your smartphone. Similarly, if the smartphone wants to get the data at the current instance, then it will publish a message to read the data on this topic, that is sensor1/get. A few points while defining a MQTT topic is there can be space in topic name. So this topic can be accepted. Data can't be published to a single MQTT topic, not all channels simultaneously. So you can't broadcast the data to all the channels. You have to publish the data to a specific topic only. Now let us see about an MQTT broker. So the MQTT broker are broadly defined into two categories. One is a standalone or self-hosted MQTT broker, and the second one is cloud MQTT broker. So these standalone brokers can be installed on your own servers, local hardware, or Raspberry Pis, while the cloud MQTT brokers are hosted by the cloud provider. In all aspects, the cloud MQTT brokers are more efficient than the standalone brokers. AWS IoT Core, Azure IoT Hub, Hive, MQ Cloud, these are few cloud providers. You can pause this video and see the comparison here. So these are few standalone brokers. The most famous is Eclipse Mosquitto, which is an open source and self-hosted. So you can go through this. So the MQTT protocol does not require internet access to function. It only needs an underlying TCP IP network to facilitate communication between the client and the broker. This is for standalone. But if you are using cloud-based MQTT broker, then both the client and the broker, it must have an active internet connection to communicate. So now let us start with configuring the AWS IoT Core for MQTT. So these are the features of the AWS IoT Core. These features are provided: security, policy, thing name, and endpoint. So before understanding these features and how to configure it actually on the AWS console, first you have to open a free tier AWS account. I have not prepared a video for this because it is a straightforward process. I will share the link in the description. You can click on the link and create your account. A free tier AWS service requires no cost for up to 6 months. You will get approximately $200 credit that will be valid for 6 months from the account creation date. This is what AWS is claiming. In this free tier, you will get almost all AWS services for free, which also includes our AWS IoT Core, which we will be using for MQTT. And even after the free period expire, there are minimal charges to use these AWS services. So once you create account and login, you will see a screen like this. Now we are interested in this AWS management console. So just click on this. This is our AWS management console where we can use all these services and configure. In search, if you write IoT Core, this service connect device to the cloud. Now let us understand the feature one by one and see how to configure it in this AWS console panel. So AWS endpoint, an AWS IoT endpoint is a unique device access URL that your IoT device uses to connect securely to AWS IoT Core. So this is how the endpoint looks. So whenever you create an account, every account will be having a unique URL or a web address which is provided by the AWS. This endpoint will stay the same. It will not change for your account. So what does this endpoint means is that the part till ATS, it is your account specific endpoint. So for each account, this part will be different. And from IoT till the end, it is a region specific. Region means which location you are. So if you are from same location and you are opening 5 accounts from same location, this part will be same. Let us see this in the AWS console, where to find this AWS endpoint. So if you come here, here is the domain configuration, and this is your domain name, that is your endpoint. So this endpoint we have to add in our ESP32 when we configure the code there. So the next feature that we have to configure is AWS certificate. So we need an SSL TLS connection with MQTT because MQTT does not provide built-in encryption by default, and without it, all communications are sent in plain text, making them vulnerable to various cyber attacks. So MQTT basically relies on the TCP/IP protocol for data transmission. By default, TCP communications are not encrypted, means that any party with access to the network traffic can tamper data or read some secure information like password and all. So that is the reason we are using TLS and SSL, basically mutual TLS. The only difference of mutual TLS is that both the client and server are authenticated, and in the HTTPS, only server is authenticated. AWS IoT security certificates are X509 certificates used to authenticate and securely connect IoT devices to AWS IoT Core. So there are two ways to create client certificate. One is generating a new certificate, which is recommended by AWS. When you generate this, you will get the public key, private key, device certificate, and Amazon root CA certificate. This is the client certificate that we are generating for our device. So you need this private key, device certificate, and root CS certificate in your ESP32 code. And the second way is upload your own CSR file to create a device that will create a device certificate for you and register a certificate that is based on private key UO. So this will create using your public key and private key and some information. You will generate a CSR file. You will basically upload this CSR file and you will get a device certificate here. So you must remember few things for a client certificate. First of all, it should be registered with AWS IoT Core. It should have a state of active, and it should not reach the certificate expiration date. So now let us see how to create this. We will create this auto-generated certificate that is provided by AWS, and later we will see how this CSR file certificate works. So if we scroll down here, in security certificates. Okay, now we will create a certificate here. Create certificate. We'll just create an auto-generated certificate which will be registered with AWS IoT, and status should always be active. Then only you can use this certificate in your ESP32. If the status is inactive, even if you use the certificate, your connection will fail. Okay, so this is our certificate is created, and what it says is download and install the certificate and keys to your device so that it can connect securely to AWS IoT. You can download the certificate now or later, but the key files can only be downloaded now. Basically, the root CS certificate can be downloaded anytime, and this device certificate, this can also be downloaded anytime, but these key files are downloaded now only. If you don't download it or if you don't save it in a secure place, then you have to again create a new certificate. So we will download everything here. It is showing a tick mark, means everything is downloaded. We'll continue. So you can see our status of our certificate is active. The next feature is AWS policy. An AWS IoT policy is the set of rules that tells a device what it is allowed to do once it connects to the cloud. So AWS policy is basically a JSON file which looks like this. So to read this, effect can be allowed or denied. Here it is allowed. Action, it is saying that IoT connect, and resource, here it has given the thing name. We will see this in the next slide. Okay, and the second action is publish, means you can publish the data for this thing name, means you can publish the data, and resource is this. Here it says that for this thing name, you are allowed to connect to the AWS IoT. It is giving the connection permission here to this thing name, and here it is giving publish also, means the device can publish the data to the AWS IoT core on this topic only. Okay, this is topic slash room slash temperature. So you can publish on this specific topic only. Other topic you can't publish for this thing name. In AWS, if a permission isn't specifically written on the pass, the answer is always no. So to understand this, suppose if this section is not here, this publish action, only I have given the connect. So you can only connect to this thing name. Yeah, you can't publish any data to this thing name. You have to specifically address every actions what you have to do. Now in security, if you go here, the policy is there. So I have already created a policy, but let us create a new one. Create policy. I will give a name as first policy here. Let's see, this is how it looks. So now I have not added this action and resources part here. Suppose I go to policy example. These are all policies example that they have given. So like let us see one that it says that publish to any topic prefixed by the thing name. Okay, so if you click this, it will automatically and add to policy. It will, this is our old one, so we will remove this connect. So it will automatically take the connect and publish action, because if you want to publish a data, you first have to connect. So it will take these two actions as allowed effect, and you can modify this the thing name you can add here, and you can add here your topic. Okay, if you see the JSON, you can see effect action resource. Action is for connect and this action is for publish. We will explore this when we practically see how we can publish, and what if we remove the publish action, what will happen. Okay, for now I will not create this. I have already created one policy. I will show you that. If we go to the JSON, the action is asterisk and the resource is also asterisk. What does this mean? So this is a wildcard character here. So action means it can perform any action, connect, publish, subscribe, any action can be performed, and for any resource. So this is a wildcard. So it is just used for development and testing purpose. It is not used in real environment. The real environment I have showed you the previous policy, specific actions and resources are used. So our last configuration for this AWS MQTT will be AWS thing. A physical device is the hardware you can touch, but an AWS IoT thing is the digital record or identity of the device inside the AWS cloud. Like for example, say there is a student named Alex. So the physical device in this case is the actual person, Alex, who is walking in the classroom. He is a physical device. And the AWS IoT thing here is the Alex digital record in the computer system of the school. I hope you can relate this example. So this is your physical device, and this is the digital representation of your physical device. Suppose this device is connected to a temperature sensor and is placed in your living room. So you can give a related thing name here, that is temperature sensor living, which will represent this device. in AWS IoT Core for your endpoint. Each device needs a unique name. This ensures that when you send a command to turn off, you don't accidentally turn off every light in the city. So no two devices can have a same name. AWS will not give you permission for that. Now let us see how to create this thing on your AWS console. So here in all devices, this is thing. Clicking, I've already created a thing here. So to create a new thing, you can click here, create thing, create, currently we will see for a single thing only. Next, we will give any name. I'm just writing first thing. This device shadow, we will understand this in the upcoming videos. Then this one is optional. This we will see in the next video. So for that, I will skip creating a certificate at this time and create thing. Okay, so your first thing is created. So you have to add this thing name in your ESP32 configurations so that when you send a request to the MQTT, it will understand for which thing name this request is being sent. This is all for this video. In the next video, we will understand about how to configure the ESP32 and we'll actually send the data to the AWS MQTT broker, that is AWS Core IoT, and we will see how to view the data on this AWS console. So if you find this video helpful, do like and share this video and don't forget to subscribe our channel. Thank you.